And in fact, I have a new little toy that I have always had the capability of, but I didn't realize I could do it. Now that I know that I can, I'm looking forward to using it. What it is the ability to write on this page.
Oh, that's kind of nice.
Yeah, it's nifty, especially when somebody sends me material. I don't have to completely redraw the picture. You know, some of those geometry problems where you have a big circle and about 14 intersecting lines. Those
yeah.
are always tough for me to do online because I kind of have to redraw the picture, but not anymore. All right, let's look at number 1.
Okay. A painter will paint walls in will paint n walls with the same size shape in a building with a specific brand paint appearance. V can be calculated with the expression NKLH. A wall is constant with the meaning of $per foot. Saying the total H is the. If the customer asks the painter to use a more expensive brand of paint, which is the fraction represented on change? Won't it be K? C?
Yeah. But yeah.
Because isn't that what's directly related with the brand?
What a strange question.
I know, that's what I kind of thought, but I didn't.
Really strange question. And when, I guess it's not a hard question because it's got to be one of those 4 letters, right? In other words, it's either N, K, L, or H, and it can't be more than 1. So obviously the height of each wall isn't going to affect anything if he wants to use a more expensive brand of paint. The only thing that will be affected is the K, the constant with units of dollars per square foot. So if you use a more expensive brand, it would be greater dollars per square foot. All right. This test does have some strange problems that I don't remember seeing problems of this type anywhere else on any other practice tests.
I know.
Here, I should
so
tell you what I mean.
3R equals 18, R equals 6, 6R equals, so it'd be 39D for 2?
Yeah. So, in other words, here's what I could do. R equals 6, so 6 times 6 plus 3 equals 39. Yeah. So I can write.
Yeah, that's what I did.
I can write on this page now.
Well, that's kind of cool.
Yeah, it is kind of cool, although not really needed that much. Maybe. I don't know. We'll see. Let's go back and do 3.
So which is equal to A times the root of 3. Isn't it B, root of A to the 3rd?
No. When you have a fractional exponent, the denominator is the root. The numerator is the exponent, the power. So we're looking for the cube root of A squared.
So it's D, 3 to the 2nd. Okay.
Yeah.
3. Sorry, I knew it was one of those 2, but I got them flipped around.
Well, and whenever you're doing these, say you had a number such as, see, now I can't resist. Say I had 8 to the 2/3 power. These are always done best by doing the root first. In other words, I could say 8 squared, 64, and the cube root of 64, but it's much better to take the cube root of 8, which is 2, so that's equal to 2 squared, 4. So whenever you have a problem where you have a number to a fractional exponent, always do the root first. And that's one way to remember which is which.
Okay. Okay.
Number 4.
The number of states that join the United States between 1776 is twice the...
Nick, let me give you one more recommendation.
Yeah.
Don't read it out loud. You're not going to be able to do that in the test, correct?
Yeah.
I mean, you're going to be surrounded by 30 or 40 other people, aren't you, when you take it?
Yeah. Mm.
Not going to be able to read it out loud. So read it to yourself just to practice that aspect.
Okay. Isn't it B? 2x equals 30?
Yeah. Some of these just kind of look hard. Some of them, they just make the thing so complicated and wordy. It's more wordy than anything else. It really shows you that wordiness does not equal difficulty.
Yeah.
Okay, number 5.
Hmm. I'm kind of unsure of how to go about this problem.
Well, what do we get if we cross multiply?
20 or 5x plus 100.
Sorry, I got to do this each time.
That's okay.
So if we cross multiply, we get 15x equals 5
5x.
times x plus 20.
Okay, yeah.
Now, if we combine, we get 10x equals 100.
Oh, okay.
So x equals 10. 10 divided by 5 is 2.
Okay. For some reason in my head, I was like,
Well, I was thinking that there's got to be a little shortcut here. Maybe there is that's shorter than the way, although it's hard to beat that way. In other words, that way was not hard. However, if I know that x over 5, if I just flip the left side, that's got to equal x plus 20 over 15. But that doesn't really help solve it. Or does it? No, it doesn't. Because I got still x's on both sides. So, no, the only way I can even think of solving it is by go ahead and solving it for x. And once you solve it for x, in other words, sometimes it looks like there's a shortcut to some of these problems. If they would have said the following, x over 5 over x equals 2, what does x over 5 equal? Well, that's a shortcut, because all I got to do is flip them both. X over 5 would have to be 1/2. Right? And that is a little confusing here because they show you what 5 over x is and they ask you what x over 5 is. So it's tempting to play around with that flipping, but it doesn't really help anything. You can't solve for x by doing that. And you really do have to solve this one for x.
Okay.
Hold on. Let me scroll down just. I always forget which one I'm on here, too. All right. Let me blow this up 1 and 2 and do this again.
Okay.
What happens if you I'm going to label that equation number 1, this equation number 2.
Mm-hmm.
What did you get if you subtract 1 from 2?
You get x minus, or is it x plus y? Yeah, x plus y.
X plus y. I was hoping you got x minus y also.
I know.
And the problem
Yeah.
was really easy. In other words,
you get,
if I had x minus y and I subtract 14 from negative 6 and I got my answer. In other words, I thought there might be a shortcut on this.
Well, I mean, it kind of makes it a little easier.
Well, except it doesn't work. It doesn't give you x minus y. It gives you x plus y. And there's a huge difference between x minus y and x plus y. I don't know what x minus y is if you told me what x plus y was.
Yeah.
Infinite number of solutions. So we're going to have to probably solve this the hard way. Do we really? There must be something else. There must be an easier way to do this. I multiplied the top by 2. I wouldn't get x minus y. Is there any way to get x minus y directly?
I'm not sure. I don't think so.
I don't think so either. Certainly subtracting the other way is still going to give me x plus y. Well, it's going to give me a minus x plus. In other words, if I do it the other way, if I subtract the bottom from the top, I get minus x minus 3y minus y. Hold on a second. Minus 14 minus a minus 6 is minus 8. What's x minus y?
Negative 4.
No, it didn't help.
Yeah.
I just realized I was thinking I could factor out the minus 1 and leave an x minus y, but it still leaves the x. Gosh, now that points up a problem that I just wasted 2 minutes on a problem trying to do it the short way.
And the short way is kind of the long way.
Well, the short way didn't get me to the answer. What's the long way to do this problem?
What I did was I took equation 2 minus equation 1, and I got x plus y equals 8. And then I had x equals 8 minus y, and I plugged that into the top equation and got 16 minus 5y equals negative 14. Then I added 14 and added 5y to get 30 equals 5y. Then y equals 6, and I plugged that back into my x plus y and got x equals 2, and then just subtracted 2.
Okay. So the long way to do it is to solve it in the conventional manner by using elimination. That's what you did, right?
Yeah.
And solve for both variables x and y. Then once you've solved for x and y, you'll know what x minus y is.
Yeah.
But, gosh, I hate this problem. I really do.
Is there an easier way to go about it?
No, I don't think there is. I think the only way to come up with this problem, well, maybe, no.
What if you multiplied the top by 3 and the bottom by 2?
Well, that's what I would have done. I would have multiplied the top by 3 and the bottom by 2, and that merely allows you to solve for x and y.
Yeah.
That's basically what you did it a little more complex than that. But yeah, if you just used your standard methods of solving this system of equations by elimination, you'll be able to solve for x and y. And the reason I hate this problem is that any person that's smart at math is going to think there's a shortcut. And they're going to try to do it, and they're going to waste a lot of time doing it. And the people that are smarter at math are actually going to take more time solving this problem. And that's what I don't like about it. Unless there really is a shortcut that I'm not seeing, Oh, there is one. Add
What is it?
both equations.
If you add them? Oh.
5x minus 5y equals minus 20.
Oh, and then if you just divide by...
Divide everything by 5, and I get x minus y equals minus 4. Bingo.
Okay.
So there was a short way. Well, I'm not sure if getting to the short way, it took me about 20 miles to get to the shortcut, whereas the long way was only 10 miles.
Yeah.
You know what I mean?
Yeah.
But there was a short way, and it was to add the two equations, not try to subtract them. Interesting problem, actually. Still not sure I like it, but verse 7.
Okay. The functions. What?
It took me a while to figure it out. I just got it.
I don't know. I'm quite confused on this problem.
Well, I'm going to do what, I'm going to show you what I did, and I'll bet you get it halfway through. Okay? I'm going to plot some points. There's the first point. X is 2, y is 1. There's the second point. When x is 4, y is 0. And when x is 5, y is minus 2. What are they asking for? They're asking for a factor, right?
Yeah.
The factor comes from the zeros. So y, or f of x, is 0 when x is 4. That makes the linear factor x minus 4.
Okay.
Right? And
Okay.
in other words,
Yeah.
when you say you're factoring something and you get x minus 2 equals 0, that makes 2 the 0. And equal to the 0. Well, we can see what the 0 is. The 0 is x equal 4. That makes the factor x minus 4. Number 8. Again, let's draw a picture. A picture can be illuminating on these.
Okay.
It goes through, first of all, we know that it's got a y-intercept at 4.
Yeah.
And it's got a slope of k, right?
Yeah.
That's a straight line. Doesn't have to be that straight line, but that slope is k. Could be negative. K could be a negative number, and then I'd have the wrong orientation on the slope. But it also has the point C, comma, D on it, where neither C nor D is equal to 0.
Yeah.
So, if I know the slope of this line is k, How can I figure the slope of the, forget the fact the slope of the line is k. I don't even need that. I just realized. So all I need is the point C and D being on the line. Now it's asking what is the slope of the line? Well, what is the slope of the line in terms of C and D? General formula for slope of the line is that, right?
Yeah.
Well, do you have 4 points?
Yes. So it would be, oh man, 0x. So, nah. So it'd be D minus 4 over C, right?
Right, because it's C minus 0 and the 0 goes away. So it's D minus 4 over C. Answer A. And that's why I didn't really care what K was. K is not even a factor. K is incidental. You don't even need to look at K in this problem. So all you need to do is draw the picture like I did. The key to this question was the y-intercept and then labeling a point on the line. And once you do that, now you remember slope is rise over run. Rise is the y-coordinate minus that y-coordinate. Run is this x-coordinate minus this x-coordinate.
Yeah.
All right.
Okay.
No calculator, okay, for this part of the test. Well, they don't hardly have any easy questions, do they?
No.
Have we seen an easy question? When have you taken a practice ACT or SAT test where in the first 9 questions there wasn't one easy one? That's a good thing, actually, for you. It's a good thing. You don't need practice on your easy questions. You need practice on these medium to difficult questions.
Yeah.
And that's exactly what you're getting. So, yeah, no, these are great practice tests for the SAT because they're made by the people that make the SAT test.
Yeah. Okay.
They are not easy.
Okay.
First of all, let's talk about what gives no solution. And because you kind of have to know that. In other words, if I had, I'm going to write over here for the moment. If I said x plus y equals 10 and x plus y equals 9, if I try solving that by elimination, let's say I subtract the bottom from the top, I get 0 equals 1. So whenever I get one number equals a different number, that means no solution. That's exactly what you get. Okay? So the question is, if I add these two equations, I get k x plus 4x minus 8y equals 11. Which is k plus 4 times x minus 8y equals 11. Well, that's not getting me anywhere. Let's take a different tactic. I can erase this over here. You understand what I'm trying to get at here.
Yeah, I think I do.
In other words, I need two equations that are inconsistent with one another.
Mm-hmm.
Well, what if I use back solving?
How did you back solve this equation?
Well, what I have to do is use a k of 12/5 and see if I get no solution. So let's try that one. Hold on. This may be the hard way to go, but sometimes it's the only way to go. 12/5 x minus 3y equals 4, and 4x minus 5y equals 7. So if I try to solve this solution and I get one number equals a different number, then that's the right answer for k. If I come up with a legitimate solution, then that's not the right answer for k, and I'll go try the next one.
Yeah.
Now, the question is what's the easiest way to solve this? Well, what if I multiply the top by 5 and the bottom by 3? That's not too bad. If I do that, I get 12x minus 15y equals 20. And the bottom I'm going to multiply by 3, which gives me 12x minus 15y equals 21. Bingo.
Okay.
0 equals 1.
Oh, okay.
If I subtract the two. Okay. So by back solving, in other words, assume that 12/5 is the answer and try to solve this system of equations, and if you get one number equals a different number, then 12/5 is the answer. If I would not have guessed right, and you know, I'm not sure that it's completely accidental that they put the first one on there as the answer. The reason is that, gosh, if it happened to be this one, I'd still be doing math.
Yeah.
And I'm not sure. There's probably a better way to solve this, although I can't really imagine what it would be other than back solving it. This might be one of those problems where your back solving is really the only way to go. In fact, the very first SAT problem you ever gave me when I came to your house was a vector problem, and you hadn't had vectors yet. And the only way to solve it without vectors was to back solve it. So there are problems on the SAT where you have to back solve. I'm convinced of that, or at least I almost am convinced of it. Let's say that I didn't pick 12/5 but 16/7. Not that I want to waste time, but I just want to illustrate something. And how come my eraser's not working? Alright, I'm going to erase them all. Let's say I started with B.
Okay.
So now I would have this. And probably the easiest way to solve this would again be to multiply the top by 5 and the bottom by 3. And that gives you 80/7x minus 15y equals 20. And it also gives you 12x minus 15y equals 21. Well, now when I add the two equations, the y's go away, and that doesn't go away. That is some number of x equals 41. which tells me I can come up with a solution to this system of equations if k is 16/7. So that's not the answer we're looking for. We're looking for a number where I cannot come up with a solution. And that was
Okay.
12/5. But all of these other numbers, I can come up with a solution. And it's all I have to do is solve for one variable. Once I can see that I can solve for one variable, I'm done. I know that 16/7 is not the number I'm looking for.
Okay.
And there may be another way to do this problem, I'm just not seeing it. Here, let me scroll down. And I'm not sure really you have to see the other way. There's all kinds of problems where back solving is the quickest way to do the problem. And that probably was a prime example, particularly when the correct answer was A. And that's why I said that might not have been a mistake. They may have made A the correct answer intentionally so that the back solver would get it fast.
Okay. Yeah, I see. Yeah. I see how you get that.
Yeah. Okay, again, let's draw a picture. Y equals x squared is a parabola that's been shifted. Hold on. I keep forgetting I got to do this. So we're looking at a parabola that's been shifted. Ow. In other words, instead of the normal parabola whose vertex would be at the origin, how do I draw this one?
Instead of normal parabola, the vortex would be at the origin. So you would put, next I put a parabola equation that intersects a line with an equation.
Shifted 11 units to the right.
Okay.
Okay, so now it's this kind of a parabola. And this is at 11. Okay. And I think that this isn't going to matter. In fact, that's a thing I can see right away. And it intersects with this equation, y equals 25, okay?
Okay.
They want the distance between those 2 points. Now, the distance between those 2 points is going to be the same whether this parabola was shifted or not, correct?
Yeah. Yeah.
Which means that I could draw the parabola like this and get the answer, only it's a little easier because the red parabola is y equal x squared. And what I need is that value and that value. And in fact, if I can just get that value, I'll have the distance. What's the x value right here where I'm putting a big X? We know the y value is 25. What's the x value on my red line? Solve this equation. If y is 25, what is x?
X is y. Oh, it's y is 25. X is 5.
X is 5, right?
Yeah.
Okay. So this point comes at 5. Well, this point over here must be minus 5 because it's symmetrical. What's the distance between those 2 points?
Distance is 10.
Yeah. Now, did I really gain anything by doing that little trick? Because that was an I'm surprised I saw it, to be honest with you. In other words, could I have just as easily solved it by dealing with the equation they gave us, which is, I think I could. Let me give it a shot. Let's see. So I want to figure out, that's y of 25, and it's equal to x minus 11 squared. Well, that's easy enough to solve for the x value. Take the square root of both sides, and I get plus or minus 5 equals x minus 11. So you get x equals 16 or 6.
Oh, and then...
That point 16, that point 6, the distance between them is 10.
Yeah.
So I really didn't gain anything. The problem was just as easy using the function they gave us as realizing that I could have just as easily used y equal x squared.
Mm-hmm. Okay. Oh, I see how you got that. Okay.
Look at 11. I'm using that a lot more than I thought I was going to on this test. All right, let's see, 11. Figure not drawn to scale. That's nice of them. Those three lines intersect at a point, and those angles relationships, if x plus y equals u plus v. In other words, this angle equals u plus w, excuse me. That angle. With me?
Yeah.
That's pretty much what the entire premise says. Now, what else has to be true? Wow. Hold on a second. Let me erase that because it's getting in the way of me seeing it. Let's see. X plus y is equal to u plus w. And we know that x plus y plus w is equal to u plus t plus z. Let's see, we know that y equals u.
And we know that x equals, x equals z.
You're correct. Well, first of all, we know y equals u because they're vertical, right?
Yeah, so you have vertical angles, but I was looking for like side angle side or like those things, but I can't see any.
I don't think we're going to need it. Let's just, if y equals u and x plus y equals u plus w, then x has to equal w. Right?
Okay, yeah.
Okay.
Oh, and if w equals z, then x has to equal z.
And yeah, w does equal z, therefore x has to equal z. So that one's true.
So if y equals u and x equals w, and they're asking if y equals w, how could we get there?
I think so.
Yeah, I
don't think y equals w. Or maybe, hold on, no.
Well,
I'm thinking. I'm trying to think visually. Sometimes it really helps to take a line. Can I rotate that line and change? Does it change anything? In other words, if I were to rotate that line 10 degrees to the right, I don't mean shift it, I mean rotate it.
Yeah.
Rotate it clockwise about this point 10 degrees. Well, x plus y still going to equal W plus U, or is it? No, it wouldn't. No, it wouldn't. X plus Y would stay the same if I rotated that line, but it changes U. So X plus Y would not equal W plus U. So I don't want to do that. Not sure where I was going with that. Let's see. What else can we write? Maybe sometimes if you just write everything you know, we know that Y equals U.
We know that W equals Z. We have that. We know that X equals T.
Oh, I already knew that Y was equal to U. Yeah, I hadn't written.
Hey.
T.
If X equals T and X equals Z, then Z has to equal T. So that 3 is true.
Okay, cool. The ones that are true are easier to prove than the ones that are false, because proving a falseness is harder than proving a truth.
Mm-hmm.
So I'm trying to figure out how we can prove that Y is not equal to W. Well, if Y was equal to W, then X would be equal to U.
But X plus Y equals U plus W.
Except we got all of these. No, these were all vertical angles. No, they weren't. The X equals W was based on the fact that X plus Y was equal to U plus W.
Yeah.
Well, I guess if I was taking the test, I would stop putting energy into it at this point and go with B.
Yeah.
And part of the reason is that these other two things were relatively easy to prove, right? And we've given this thing 2 minutes and we cannot prove that Y equals W. And yet, if it was easy to prove, we would have proved it by now.
Yeah.
So I think it's safe to say that Y can't be equal to W. If Y is not equal to W, then Y isn't equal to Z either, which makes Y not equal to X and Y not equal to T, all of which are true. But I still am having difficulty with figuring out how to not prove it, how to prove that that's false, number 2. Not sure I can do it. Yeah, if I rotate that line, I change Y and W. No, I don't. I change Y only. In other words, if I take that line and rotate it, it doesn't change W, only changes Y. But also rotating that line changes everything else, so I can't do that. But that would be one way to prove it, that they're not equal, is to prove that if I rotated this line, it does not change the truth of any of these, but it does change angle Y without changing angle W. So that would be a method of using. I just can't do that here because I can't rotate that line without changing stuff.
Yeah.
I can't rotate the horizontal line without changing these premises here also. So I'm not sure what else to do other than go on. They do have answers on these, so I suppose it would be worth. But I'm at this point, I'm 99% convinced that we got the right answer.
Yeah.
I just, proving a negative is always harder than proving a positive. Or rather, disproving something is always harder than proving it, I think. Well, not always. All right, let's look at 12.
Okay.
Obviously, you would never take this amount of time on each question that we're taking.
No, but it's kind of nice to like go through, and these questions are like kind of the ones that I'm rusty on.
Well, it is nice in another way also, and that is, I once had it explained that the difference between Asian schools and our country's schools is that we spend an hour looking at 20 questions, and in Asian mathematics, they spend that same hour looking at 4 questions from 5 different angles each. And they end up with a better math education by doing that. Rather than just going through 20 problems that are all relatively the same, if you pick 5 problems and do each problem in 4 different ways, you understand the problem better, I think. So that's kind of what we're doing here, is we're really breaking apart these problems completely and trying to look at them from all different angles.
Yeah. Okay. I like that. Okay. 12.
12. God, either I'm getting stupider or they're getting harder on these things. I wonder if by going to practice test 3, we went to a harder practice test.
Awesome. My thing, how I was going to approach this problem was going to be plug in C and D for X and Y. Is that correct?
I don't think so. Notice that if you do that, you will be able to solve for D, but it will be in terms of A and C.
I know, that's the only thing that I don't know how to single out A.
We got to be able to figure out how to determine D in terms of A. Well, again, let's draw a picture, because the one they've given us here is in x-intercept format, so it's relatively easy to draw, right?
Mm-hmm.
In other words, the intercepts are at 2 and -4. So 2 and -4. And A is non-zero, so I have a parabola. Let's assume that it opens up like that. And I actually know where the x-coordinate of the vertex is. What is it?
It is at 2 and 4, it's at -2.
Add them together, divide by 2.
Oh, -1, I'm sorry.
And you want a point that is equidistant from both of these intercepts. -1 is 3 units away from -4, and it's also 3 units away from +2. So now we know at least the x-coordinate of the vertex. In other words, we know what C is. So now we can do exactly what you were saying. We know C is -1. So let's plug it in. And now we'll end up with an equation where D will be defined in terms of A only. So y equals A times -1 -2 times -1 plus 4. No, I thought I was on the right track, but I'm not. Although you, I believe, half the solution. Let's see, if I go back here and I label that D, and I don't know D because I don't know A. In other words, there's no way to figure out what D is. Because based on A, if A was bigger or smaller than the vertex, would be in a different spot. The y-coordinate of the vertex would be in a different spot. The x-coordinate of the vertex is always going to be in between, halfway in between the zeros. So, what else can we do? We can multiply that together. Does that help? We end up with a times x squared plus 4x minus 2x plus 2x minus 8. And so that's ax squared plus 2ax minus 8a. So there's our equation.
Mm-hmm.
And we know that when x is, we know that when x is 2, y is 0. So I'll make y 0, I'll make x 2, and that gives us this. Oh, man.
Well, that's... yeah.
Oh, I thought I was so clever for a moment there. Maybe I used the wrong point. Let me make y 0 and x minus 4. I bet the same thing happens. Maybe not, though. In other words, I also know that this point, that point being x equals minus 4, y equals 0. That is also on our equation. So 0 equals 16, yeah, same thing's going to happen. 16a minus 8a minus 8a.
Huh. Do we want to look at the answer for this problem?
No, not yet. We only got 2 minutes. I want to give it a little more thought. When are you taking this? You're not taking the SAT for a little while longer, huh? We'll probably have another session. I'm convinced I can solve this. I just got to see the right way to look at it.
Sorry?
I said I'm convinced I can solve it.
Yeah, I take the SAT.
And it might be as easy as figuring that out. In other words, I know that that's the vertex. No, that's the x-coordinate of the vertex. So that doesn't work either. Anyway, I'll let you go, and I won't hold you while I'm trying to figure this problem out. But I'll figure this out by the next time we meet. And we can begin with it. 12. Should be easy to remember which one we're working on, huh?
Yeah.
All right, Nicholas. Oh, God. I'm not sure why it feels like it's been such a struggle, but it feels like it has. I would have hated to take this test. I would have taken an hour to do the first 12 questions.
Well, it's kind of funny. The new thing that they're teaching in school is a lot more like guessing methods than they are like kind of teaching how to solve these problems.
Well, I'm a huge believer in back solving or picking numbers and back solving. Maybe back solving is the way to do this one, although I don't think it is, to be honest. I think I can solve this the normal way. I just got to figure out how to do it. But maybe back solving is the answer on this one also. I don't know. I need to look at it a little. I got a feeling this is really going to be the way to go.
Huh.
Well, that gives you the x-coordinate of the vertex, minus b over 2a. Anyway, I'll talk to you later, Nick.
Okay. Sounds good, Mr. Cohen. Thank you.
All right. Bye-bye.
Bye-bye.